Okay, I'm going to walk you through one more test of independence. So the problem says, 1 year after Trump took office, a nationwide random sample of registered voters were surveyed as to whether they thought a female could win the next presidential election. The observed responses are below. Test for independence at the 5% significance level. So this is, again, just our alpha level. So here's our observed table. I did take a minute to add up all three of my columns as well as my rows. And then I had a grand total of 1,000. And we're going to need that information to come up with our expected table. So as far as our expected goes, I showed you how to find the expected for Democrat and not sure. So remember, we take the row total times the column total divided by the grand total. So I did 450 times 110 divided by 1,000, and I would expect about 49.5 people in that cell. Now, in this case, you have 9 cells, and we would not expect you to fill in all 9 cells by doing this. So what you can do is utilize your calculator. So in my calculator, I'm going to start by going into the matrices, so second matrix. Remember, if you want to input a matrix, you go to Edit. So first we start with the dimensions. So this is a 3 by 3, 3 rows, 3 columns, and I've already inputted my matrix here. Next, I'm going to go to Stat, Test, and then arrow up to get to the very bottom. So I want C, a chi-square test. So observed, I put in matrix A, expected was matrix B. If you wanted to change this, you could go into the matrix and then just select the number or the letter that you want. Shoot, of course I have to do that again. So I go all the way down. So this is a little backwards here. So we already have our chi-square test statistic, which we'll be calculating later, as well as our p-value and degrees of freedom. But the reason I did this is because it automatically populates that matrix B with our expected. So if I go back into those matrices, select B, and hit enter, there is my expected. So now for our hypotheses, so our null and our alternative hypotheses. The null hypothesis is political party and opinion on whether women can win are independent, and then our alternative would be that political party and opinion on whether women can win are not independent. Remember, you do not want to say dependent, we just stick with not independent. Then for our assumptions, so we have counted data, it was the number of people. Expected is greater than or equal to 5. Well, my lowest was 22. Third was random and independent, and it does state that it's a random sample. And then finally, fourth is our observations are less than 10% of the population, and there's more than 10,000 voters. So next up is my test statistic. So I take the observed minus the expected squared divided by the expected, and I add all of those components up. So remember, you need to show me at least the first and the last. So we can do first plus ... plus our last component for a test statistic. Sorry about that. So our test statistic turned out to be 3.02. So the next thing we need to do is calculate the degrees of freedom. So remember, it's the total number of rows minus 1 times the total number of columns minus 1. So we end up with 4 degrees of freedom. So finally for our p-value, well, we actually already saw this when we did the test in our calculator, but we could check this again by going to second vars, chi-squared CDF. So remember, we put the lower bound, so that would be our test statistic of 3.02, a ridiculously large number, and then the degrees of freedom. So I end up with p equals 0.554. Now that's a pretty large p-value, and it's definitely greater than that 0.05 significance level we said before. So for my conclusion, I would say with a p-value greater than alpha equals 0.05, I fail to reject H0. I have no reason to believe political party and opinion on whether women can win presidency are not independent. And that's all for our chi-squared test of independence.